Well, greetings, Mr. Colazar's class. We're going to start putting a couple sections together. So in video 10-4, what we're going to do is convert between mass and the number of particles. Now remember, our stopping point is going to be the mole. So we've continued to talk about that mole. It's going to be our counting term there. So what we're going to look at is converting between mass and the number of particles. You've got this box on your page. You're going to need to write a little bit smaller, but we're going to start out with remembering the idea that 6.02 times 10 to the 23rd particles of whatever substance we have, we'll just call it X for now, is equal to 1 mole of X. And then our new step from our last section was that if we have the amount of moles of X, we could find out how many grams of X we have using the periodic table. So the PT is what we'd use there. So what we're going to look at is how we can go from one to the next step to the next step. So combining our two steps together is basically what we're going to look at. So our example for the beginning in this box would be if we started out with the number of particles. That could be either atoms, ions, formula units, or molecules. So the number of particles of X, whatever X might be. And what we're going to do is we're going to be able to look at converting that to moles by 1 mole of X over the number 6.02 times 10 to the 23rd particles. And we could go from number of, now that we're in moles, we could then go 1 mole of X is going to be equal to the amount of grams of X using that periodic table. So the atomic mass from the periodic table. So we can go from number of particles to moles, number of moles to grams. Or just the opposite, we could start out, if you know the amount of grams of, say, X, you could take that and go from grams of X on the periodic table, PT, over 1 mole of X, and then from there you could multiply that by 1 mole of X over 6.02 times 10 to the 23rd particles. So we can convert between particles and moles and number of grams, or grams to moles, moles to number of particles. So to use this information, just at the top of the page, I've put down 1 mole of X equals 6.02 times 10 to the 23rd particles, whatever it might be, equals the number of grams of X. Remember, we need to get that information from the periodic table. So our first problem, how many atoms of gold are in an alloy bullion of that weighs 31.1 grams? That's a gold brick. So our first step to analyze, we're trying to find the number of atoms, and we're given that we have 31.1 grams of AU. So we're going to start, we need to first go grams to moles. So on the periodic table, 196.97 grams of AU, that's from the PT, equals 1 mole of AU. And once we're in moles, grams cancel grams. Once we're in moles, 1 mole of gold is equal to 6.02 times 10 to the 23rd gold atoms. So in the end, we end up with about, calculating wise, 9.51 times 10 to the 22nd gold atoms. So making sure as we look through, moles cancel the moles, numbers on top are multiplied, numbers on bottom are divided. So we've went from mass to moles, stopping at that number, or excuse me, mass to particles, but we first had to stop at the number of moles, our conversion point. So we got a party balloon filled with 5.0 times 10 to the 22nd atoms of helium gas. What is the mass of helium in grams? So our first idea, looking to solve for mass in grams of helium, we know we have 5.0 times 10 to the 22nd atoms of helium. So our first step is we need to go from particles, so atoms of helium, to moles of helium. And once we're in moles, atoms cancel atoms. Once we're in moles, we can go to grams of helium. Molecular mass from the periodic table, 4.00 grams of helium equals 1 mole. Remember, that's from the periodic table. So numbers on top multiplied, numbers on bottom are divided, and in the end, when we calculate out how much helium we're going to have, we get about 0.365 0.365 grams of helium. So in our last problem, what we're going to look to do is we're going to try to calculate how many formula units are in a sample of sodium chloride with a mass of 75 grams. Now when we look at formula units, metal and a non-metal. So once we start here, sodium chloride chemical formula, sodium Na plus 1, Cl minus 1. So our formula NaCl. So in this case, we need to first find out what the mass of sodium chloride is. So in our last section, we have 1 sodium, 22.99 grams, 1 chlorine, 35.45 grams, 1 of each. So when we add those two totals together, we get a mass of 58.44 grams per mole for sodium chloride. And that number is going to be important here in just a minute. So what we're going to do is we need to start with our known amount. And our known amount is 75 grams of NaCl. Now to go from grams of NaCl, 58.44 grams of NaCl over 1 mole of NaCl. And then our second conversion, we want to end up with formula units, so 1 mole of NaCl equals 6.02 times 10 to the 23rd formula units of NaCl. And in the end, when we multiply numbers on top divided by numbers on bottom, we end up with about 7.73 times 10 to the 23rd formula units of NaCl. So in the end, what we've done is converted between the mass and the number of particles, but we always need to stop at the mole first. So that's our key idea as we're going forward. I'll let you continue working on our problems now.